right, let's start. Okay, so if you remember last time, what I was trying to show you was why the trig functions were these values. You know, it's not like one day somebody said, we're going to choose these sine of 30 degrees to be a half, sine of 60 degrees to be radical 3/2. You know, we're just going to choose that for fun, no questions asked, you know, and see what happens. You know, these values came about mathematically, you know, by some kind of proof. And I was trying to illustrate that proof, you know, how using certain triangles, you can determine certain trig function values. I mean, you don't have to memorize these because they're programmed into our calculator. I think before calculators, they used reference tables. But, you know, I'm not going to ask you to prove why. I'm not going to ask you to show why sine of 30 degrees is a half, or why, you know, tangent of 45 degrees is one. I'm not going to ask you to prove that. I just wanted you to see why those values are true, why these are true. That's all I was trying to show you. I know once you get sine and cosine, remember, you can get all the trig functions. You know, tangent you can get in terms of sine and cosine. You can do that. Okay. All right, and there was another example we did. Last time, the example here I did was sine of theta equals a third, but I think it might be better to do this one instead. That's why it says example 5. So originally I was going to let you guys try this. Since I messed up the example, I think it'd be better if I do it with you guys. I'm hoping to get to a worksheet I made using Google Docs, but you know, we'll see depending on time. Worst case is I let you work on it next week. Okay, something on my desk. Get it off. 1 second. Something fell off my desk. I just had to get it. So, right. Anyway, so let's suppose theta is such that tangent of theta is a third. We don't know what theta is, except that theta is acute. No, it's between 0 degrees and 90 degrees. To handle the trig functions when theta is negative or greater than 90 degrees, you know, that's where you'll see that in Math 105, which is pre-calculus. They use the unit circle to generalize that. That's a different story. What's nice is we don't have to figure out what theta is to get all the other trig functions. Okay. So we don't have to. What we do have to do, though, is form a right triangle. You have to form a right triangle where theta is an angle in it, you know, an angle that's not 90 degrees, besides the 90-degree angle. And we have to label the sides so that this is true. Well, that's what we do here. So it's almost like, you know, you're coming up with a triangle that if I gave you the triangle, you know, if I gave you this triangle, in other words, right, you would see, well, tangent of theta has to be 1/3. That's the kind of triangle you want to make. So we have a right triangle here. Tangent of theta, we know, is opposite over adjacent, right? So SOHCAHTOA. So we can set the opposite side, we can label that as 1. We'll set it to be 1. We can also set the adjacent side here to be 3. And that's good. So now we have a right triangle such that this is true. Okay, but if we want to get all the other trig functions, we need the length of this unknown side. The unknown side I labeled as x. We need to know what the length of that side is. How do we do that? Pythagoreans Theorem. Okay, so we know that x squared, the unknown I put on the left. That's what mathematicians do. We have x squared is 3 squared plus 1 squared. X squared is 3 squared plus 1 squared. Okay, well, let's figure out what x is. We know 3 squared is 9, 1 squared is 1, so x squared is 9 plus 1, which is 10. So we know x squared is 10. Okay, that tells us x has to be the square root of 10. So that's just by, you just take square roots. Excuse me. That's all. So now that we know what the third side is, we can get all the other trig functions. So let's do that. Again, I did email you the notes. If you don't have the notes, if you're not getting the notes, please let me know. Okay, so we have our triangle here. Okay. What we want to do is we want to get all the trig functions. Sine of theta, right? That's opposite over hypotenuse. Here's theta. Opposite over hypotenuse. Opposite over hypotenuse. Cosecant we know is 1 over sine. So since sine is a fraction, we just flip it. 1 over means you flip it, you invert it, so you get this. And that's the same thing as just radical 10. Anything over 1 is itself. Cosine of theta, right? That's adjacent over hypotenuse. Adjacent over hypotenuse. We have 3 over radical 10, right? Cosine is adjacent over hypotenuse. Secant of theta, right? That's 1 over cosine. So that's the reciprocal of this. In other words, you just flip it like this. You just invert it. We know tangent of theta is a third. So that tells us cotangent of theta is 1 over tangent, which is, the reciprocal of this, which is just 3. 3 over 1, which is 3. So that is what we get. All right. Any questions on that? Okay. In that case, let's keep going. All right. So here's the example that I tried to go through, although I don't think I finished it last time. So I figured it wouldn't hurt to go through it again. So let's do that. Okay. So here we have a right triangle. Okay. Now basically here it's different than the last example. I'm telling you what theta is, the angle here, which is 37 degrees. I'm telling you that. So we're basically assuming that, I guess. I'm telling you here that the adjacent side, adjacent meaning it's adjacent to 37 to the angle, that's 40. So what we're going to do, we're going to figure out what B is here. And not only that, we're also going to figure out C, but we're not going to use B. So in particular, we're not going to use Pythagoreans Theorem. I know theoretically you could, but I want us to practice using trig. Okay. Okay, so actually before we get to this, let me do this. Well, if we want to find B, although I guess you probably know already, but let me just say this anyway. Well, notice that B is the opposite side, right? The opposite side relative to the angle. 40, we said, is the adjacent side. Okay, well, which trig function should we use? If we have opposite, we're working with, and adjacent. Opposite, adjacent, let's use tangent. Right? So we know, in other words, that tangent 37 degrees is opposite over adjacent. B over 40. So from here, B is our unknown. So cross multiplying by 40, what do we get? We get B is tangent of 37 degrees times 40. Okay, now what do we do next? Well, we should get tangent of 37 degrees. That's where the calculator comes into play. I know the iPhone calculator does have this. You may have to, how do I say this, rotate it on its side. I'm sure you know what I mean. You get a lot more features from the calculator. And you want to make sure you're in degree mode. Desmos, the calculator in there that you could download onto your phone, that actually not only has the 3 trig functions, sine, cosine, tangent, it has cosecant, secant, and cotangent, except, from what I saw at least, it's automatically in radian mode, and you can't switch it to degree mode. So if you use the Desmos calculator, you would have to convert this to radians. I mean, that you could do that. I'm just saying that's something that's a step extra step you have to take. I'm sure the Android phone has a calculator, like the iPhone does. But either way, you get tangent of 37 degrees. Turns out to be this. And make sure, again, you're in degree mode. We're in degrees here. If you're in radians and you type and you try to get tangent of 37, you're not going to get this answer, right answer. Anyway, from here, the tangent of 37 degrees is this. So essentially, we're just plugging in. We're multiplying this by 40, and we get b is this, rounded to 4 decimal places. Let me just pause the recording.